The big topic today is green hydrogen.
Germany has a long tradition, starting over 100 years ago with municipal gas, which in some cases contained up to 50% hydrogen.
In the past, it was mostly produced from natural gas, and that, of course, was then associated with corresponding CO2 emissions. That's something we want to avoid today. And the big talk today is green hydrogen, which is CO2-free in both production and use.
That is correct. We therefore also need a green way to produce hydrogen, namely through electrolysis. Because at the moment, hydrogen is mainly produced from natural gas, and of course, we don't want to have that in the future. In this respect, there is green electricity and a green option for the production of hydrogen.
And the whole process is now being scaled up accordingly to orders of magnitude that will probably be 10 times or more the current production. In the last 20 years, especially here in Germany, the main goal of the expansion of wind power plants and also of solar or photovoltaic plants has been to generate electricity. And what has increasingly proved to be a problem, which was actually not surprising, is that we have energy producers here that supply energy completely detached from consumption. So let's say what's actually clear to every school child. A solar plant supplies electricity when the sun is shining, but it just does not supply electricity when it's nighttime and dark. But we have to establish security of supply, and that has had two consequences. On the one hand, we lack the medium for storing energy, and on the other hand, the increasing expansion of renewable energies also places much higher demands on energy generation itself. This means that we need a renewable energy substance with which we can store electrical energy, so to speak. Batteries can only do that for the short term, and they are not suitable for long-term storage. And that's where hydrogen enters the picture.
You can really say hydrogen is nothing new, but it is definitely different from what we've had so far. And if we want to use it on a large scale in the future, we obviously need the appropriate technology.
Energy generation in wind turbines is getting larger and larger. Today, we have wind turbines at sea with a capacity of up to 15 megawatts. 10 years ago, no one would have imagined that such a feat was possible. And these turbines, with these enormous outputs and rotor diameters of 200 meters, naturally rely on very precise control. This is where we offer a range of sensors that detect, for example, the angle of the blades or the nacelle that has to be turned to face the wind.
That is correct, and this is where our interface technology comes into play. A standard signal is generated from the sensor signal. This is then passed on to control systems, controllers, so that the wind operator can also see exactly what is the condition of his turbine, how much power is being generated, does anything need to be done if necessary?
And not to mention, subsequent signal processing is required here as well. And that's becoming increasingly important, more and more significant, because this technology really does have a certain degree of maturity today. And wind turbines are also supposed to have the character of power plants. In the past, people simply said, well, when the wind turbine turns, it provides electricity. That's just not good enough. If you want to rely on that, a wind turbine also has to be able to support the grid. All of this places higher demands on the control of the plant, and these are major challenges that research in Germany is currently addressing very intensively, and there's still a lot of room for improvement.
There is no way around hydrogen.
Correct.